Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Count number of bad pairs, Leetcode 2364. In this problem, we are given a zero index integer array nums. A pair of indices I, j is a bad pair if I is less than j or j is more than I and j minus I is not equal to nums j minus nums I. That is, the difference between the indices is not equal to difference between the numbers at those indices. And we should return the total number of bad pairs in nums. Then in example 1, for the given nums array, we have the indices like 0, 1, 2, 3 and the pairs we can form are between the indices 0, 1, 0, 2, 0, 3, then 1, 2. We can't take 1, 0 because j should be more than I, and then 1, 3, and the last pair will be between 2, 3, and the difference between the indices will be 1, 2, 3, 1, 2, 1, right? And the differences between the numbers at those indices will be 1 minus 4, that is minus 3, 3 minus 4, that is minus 1, and 3 minus 4 again. So again we will get minus 1. And for the pair 1, 2 and 1, 3, the difference will be 3 minus 1, that is 2, and 2 again. And for the pair 2, 3, the difference in numbers will be 0. So now we can check which of the pairs is good pair or the bad pair. So here we can see that the difference in indices is not equal to difference between the numbers. So it is a bad pair. Then this is also a bad pair. This is also a bad pair. This is also a bad pair. This is a good pair. And this is also a bad pair. So the total number of bad pairs we get is equal to 5, which will be our answer. Then in example 2, for the given nums array, no matter which pair we form, all of them will be good pairs. For example, for the pair of indices 0, 1, the difference between the indices and the numbers is 1. So it is a good pair. So none of the pairs will be bad pairs. So because of this, we will return 0 as our output. Now in terms of solution, one of the naive approach can be that we check every possible pair I, j and check if it qualifies as a bad pair using the definition of the bad pair, like we did in the example walkthrough. We can do that by running two nested loops using the iterators I and j and count the bad pairs. But the time complexity of this approach will be O of n square due to two nested loops. And the question is, can we do better? And the answer is yes. Can we do some kind of pre-processing that can help us avoid the nested loops? For that, let's look at the definition of the bad pairs. For the indices I, j, where I is less than j, j minus I should not be equal to nums j minus nums I. Now the problem with this definition is that it contains an inequality. This prevents us from doing some kind of pre-processing. So instead of this, let's focus on the definition of good pairs. Maybe that can help. So the definition of good pair is j minus I should be equal to nums j minus nums I. And still we can't do any pre-processing because two indices are on the same side, and because of this, we will still need to run the nested loops. But we can rewrite the equation like this. Now we can see some kind of a repeating pair. If we denote kj as j minus nums j and ki as I minus nums I, then for the pair of indices I, j to not be a bad pair or to be a good pair, ki should be equal to kj. Now because I is less than j, we will see ki before kj. So we can traverse the array, say with iterator j, and compute kj and check how many times we have seen it in the past, as those occurrences will represent ki's, and from these we can determine the number of good pairs I, j that can be formed. For example, at index 3 when we calculate k3, we will get 3 minus 3 equal to 0, and similarly at index 1 we will get k1 as I minus nums I is equal to 0. So because of that, we can form a good pair between them, which will be 1, 3. And suppose we had two more elements, say 2, 5. And for index 5, we will have k5 equal to 5 minus 5, which is again equal to 0. So now for this index, how many good pairs can we form? We can form two, one with 3, that is 3, 5, and one with 1, which will be 1, 5. So because of that, we will get total of 3 good pairs. And now, because we have to track these values, kj's, which data structure can help us with the lookup? The answer is Hashmap because the lookup time complexity of Hashmap is O of 1. Now let's quickly see this in action. Let's take example 1 where we had elements 4, 1, 3, 3. So now we will calculate all the keys kj which will be equal to index j minus nums j. Now we will start the iteration. Let's also initialize the hash map to store these keys. Then for index 0 we will have k0 as 0 minus 4, that is minus 4, and we are seeing it for the first time, so the count is 1. Then at index 1 k1 will be equal to 1 minus 1 equal to 0, and we are seeing it for the first time as well. Then at index 2 k2 will be equal to 2 minus 3, that is equal to minus 1. We are seeing it for the first time as well. Then at index 3 k3 will be equal to 3 minus 3, that is equal to 0, and we already have a key with 0 in it, so that means we are seeing it for the second time, so we can form a pair from it. So number of good pairs now become 1, and now the count of keys with value 0 now become 2. So this is how we can actually calculate the good pairs. In this case there was only one good pair. Now let's look at example 2. Again we can create a hash map and start the iteration. Key 0 will be equal to 0 minus 1, that is minus 1, and we are seeing it for the first time. Then at index 1 k1 will be equal to 1 minus 2, that is minus 1, which is already present in the hash map. So we can form a good pair between these two indices, and now the count for the key minus 1 becomes 2. Then at index 2 k2 will be equal to 2 minus 3, that is minus 1, and we already have this key in the map with value 2 in it. So number of good pairs we can form are 2, because 3 can form a good pair with 1 as well as 2. So total number of good pairs now become 3. And now we will set the frequency in the map to 3. Then at index 3 k3 will be equal to 3 minus 4, that is minus 1, and we already have minus 1 as a key in the map. So we can form 3 good pairs of 4 with 1, 2 and 3. So because of this, now the count of good pairs becomes 6. So this is how we will calculate the good pairs, and so far so good. But in this problem, we have to return the total number of bad pairs. So how can we do that? And for that, we can derive the bad pairs by subtracting good pairs from the total pairs. And now the question is, how can we calculate the total number of pairs? Let's derive it together. To form a pair in an array, we have to have at least 2 elements. Let those elements be E1 and E2. And total number of pairs we can form from them is 1, that is E1 and E2. Now suppose we had 3 elements, E1, E2 and E3. Then we can form the pairs between them like E1, E2, E2, E3, E1, E3. Hence total of 3 pairs. And now suppose we had 4 elements with 4th element being E4. Then how many elements can this E4 pair with? And the answer is it can form pair with all the 3 existing elements. So it will form 3 additional pairs. Hence we will get total of 3 plus 3, that is 6 pairs. And now let's stretch it a bit. Suppose we had 5th element as well, which is E5. This new element can form a pair with all 4 existing elements, resulting in additional 4 pairs. Hence total of 10 pairs. And mathematically speaking, we are choosing 2 elements out of n elements to form a pair, and this can be represented by combinations formula NCR, where we choose r items out of n items, which is equal to n factorial divided by r factorial and n minus r factorial. And here r is equal to 2, that is we are doing NC2, which is equal to n factorial divided by 2 factorial and n minus 2 factorial, which we can rewrite as n into n minus 1 into n minus 2 factorial, and 2 factorial can be written as 2, and we can rewrite n minus 2 factorial as is. So these two will cancel out, and hence NC2 will be equal to n into n minus 1 by 2. So that's why for 4 elements in an array, we will get 4C2, that is 4 into 3 by 2 equal to 6 total pairs. So coming back to our examples, for this nums array, total number of pairs that we can get is equal to 4C2, that is 6. And we had only one good pair. So because of this, the total number of bad pairs will be equal to 5. And similarly for the example on the right, total number of pairs again is equal to 6, and we had good pairs as 6 as well. So that's why the total number of bad pairs is equal to 6 minus 6, that is 0. And now in terms of time complexity, it is O of n. Since we traverse the array only once, And in terms of space complexity also it is O of n, because for each index we are storing kj in the hash map. Now let's jump into the code part. First, let's create a hash map to store the counts of ki's. That is the difference between the index and the number. Let's also initialize number of good pairs equal to 0. And we are using long here to avoid the integer overflow and get the length of the nums array as n. Now we will iterate through each index j in the nums array and calculate the key kj as j minus nums j and check if the key has been seen before using the hash map. If the key is already present, then we will add the count from the hash map to the good pairs count and increment the count of this key in the hash map. But if the key does not exist, then we will add the initial count of 1 for it. And once we are done with all the indices, we will calculate total pairs as n into n minus 1 by 2. And again we are using long to avoid the integer overflow. And because of this, we have to cast this integer n into n minus 1 by 2 to long. And in the end, the difference between the total pairs and good pairs will be the bad pairs, and that will be our answer. Now let's submit this code. Cool. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.